Let's find the derivative for the function g of x, and notice that for g of x, this is the function that's defined in terms of an integral. It's the integral from 1 to x, 1 over t to the third power plus 1 dt. So whenever you're trying to find the derivative of an integral, we have to use FTC 1, the fundamental theorem of calculus part 1. And what it says is that derivative will cancel out the integral, and then you just have to do some substitution of the variables. Notice that here we're using t, but then for the limits of the integrations, it's in terms of x, or sometimes from a number, like 1 to x. Anyways, let me show you how this works. So I will write down g prime of x, representing the derivative of g. But then what's happening on the right-hand side is that I'm going to differentiate that. So let me use this notation. d dx, differentiating this part. So it's the integral 1 to x, 1 over t to the third power plus 1 dt. So FTC1 says, derivative and integral will cancel each other out. The remaining expression will almost stay the same, but you have to look at the expressions. For the number, don't worry about that. For the x, what you need to do is plug in this x into the t. That's all. So the answer for this is just 1 over x to the third power plus 1. And this is it. That's it. However, sometimes you may have some kind of like more complicated things, maybe like sine x, or maybe x to the fifth power, things like that. But then in that case, you just have to use the chain rule, but the procedure right here is the same. All you need to do is plug in the variables into the integrand. That's it. So g prime of x is equal to 1 over x to the third power plus 1. That's it. And this is my new microphone. I hope the sound quality is better. Let me know if you guys like the sound quality or not.